So circles are possibly the best example for showing static variables and how they work. So let's go ahead and take a look at creating a new class, circle class. Right. So that should be pretty straightforward. Circle. All right, now circles are defined by a number of various things. First off, circles are defined by, most importantly, their radius. Just like a square is defined by the length of its side, a circle is defined by the length of its radius. You could argue with the diameter, but honestly, it's best to do the radius. And of course, we are going to make it private. Then there's one other important variable we need for circles. The variable that we need over here is pi, right? So private double pi is equal to, and we always know what it's equal to, so we're going to define it over here, 3.14159. So our first aside is that honestly it's pretty useless to make pi private, right? Because pi is just such a useful number. So for instance, if I make a circle driver over here, circle driver, right? What am I doing? We need a PSVM, right? It would be really useful to be able to, look at pi and be able to reference it all the time. So you could make it public. But of course, making it public means that we can change pi, which would be terrible. So we use the keyword final, which means that nobody can change pi. Final is the word for constant. When you use final, it means unchangeable, and you can use it on all sorts of things. You can use it on classes, which gets into inheritance, meaning nobody can inherit this class. It also means for methods that nobody can override this method, which is pretty nice. But most importantly, we use it in discussions of variables to create constants. Okay, so let's go ahead and just make the basics for our circle class right now. So we're going to make a constructor, public circle, given a radius, double radius, this dot radius is equal to radius. There we go. And we're going to go ahead and do public diameter. We'll skip that, and we're just going to count because that's not so important. We'll go ahead and do public double area, which is equal to 2 times return 2 times pi times, or nope, that's area is pi r squared. So pi radius times radius. Right. I was getting the circumference. 2 pi r is the circumference. So we've got that. So let's go ahead and go to our circle driver. Right? And let's go ahead and create an array of circles. Circle array circles is equal to new circle array. Now let's go a bit crazy and create 1 million circle objects, right? So 1, 2, 3, 4, 5, 6. There we go. 1 million circle objects, not 10 million. Okay. So let's go ahead and create a loop. And what we're going to do is that we are going to say for int I is equal to 0, I is less than circles dot length. We are going to say circles I. We're going to say the ith circle, the circle at index 0, is equal to a new circle with a radius of I plus 1. Okay, so in other words, all we're doing over here is saying that circle, the circle at index I, which is initially null, we're instead going to store the memory location of a new circle, which has a radius of I plus 1. So index 0 is going to have a radius of 1, index 1 is going to have a radius of 2, index 3 is going to have a radius of 3, and so on and so forth. This will just make, because I don't want a 0 radius circle. That seems a bit silly. And we're going to go ahead and then go and print out each of these guys. So for int I is equal to 0, I is less than circles dot length. We are going to go ahead and sout circle dot circle dot. We're going to print out circles I dot get dot area. So run it, and actually run surprisingly quickly. You know, that was a million things. Surprisingly, it ran fairly quickly. So on the other hand, but there's a reason for me making a million of these things. So let's go ahead and take a look at debugging this thing. So debugging is a really useful tool. I'm going to double click here to put in a breakpoint. Okay, actually, I'll put it over here right before we hit the for loop. Or maybe, just to be super explicit. Don't need that. Yep, so right here as we make the for loop. So yeah, it says for each, replaceable with the for each. Ignore that. So we are just going to run, now rather than hitting this button, I'm going to use debug. Shift F9. So run it, allow access, and what it does is that it allows us down here to see how we are doing. And this might be a bit hard to see on your computer, but notice that it has the current state of my program. We have args, which is over here. Main takes in a string args. This is useful if you're using it from the command line. And then we have our array of a million circles over here. Right, 900. Here's the first 100. Here's the rest of them. I can double click to see them. And so we can actually look at our individual a million circles if we want to. So for instance, circle 0 has a radius of 1 and its pi variable is 3.14159. Index 1 has a radius of 2. Its pi variable is 3.14159. 2 has a radius of 3. Its pi variable is 3.14159. See a theme here? 75 has a radius of 76. It also has a pi variable. So, now, you should be thinking to yourself, well, it makes sense for everybody to have their own copy of pi, right? Not a copy of pi, their own copy of a radius, right? The radius is unique to each circle. That's what defines the circle to be a circle. But it doesn't make sense for everybody to have their own copy of pi, right? We've got a million circles. Really, pi's never going to change between them. So we're wasting a double for each of those. So that is 64 bits for a double. We only need one value of pi, so there's 999,999 wasted variables for pi. So yeah. Oops. Nope. 64 times 9999. That's a lot of, so that ends up being, divide by 8, and that ends up being close to 8 megabytes of wasted space. All right, so this is how many bytes are being wasted. All right, not too many actually, all things considered, but suppose you had 20 variables or 100 variables that didn't need to be replaced. So over here, what we can do is use that esoteric keyword, static. And now notice that it's been italicized over here. And what that means is that no individual copy of circle now owns pi. Pi belongs to the entire class. It is a static variable, or also known as a class variable. Static methods are also known as class methods. So it is public. Everybody can see it. It is static. It belongs to the class, not to the individual circle. Another way to think about this is that every single circle shares one variable of pi, but everybody has their own radius. It's an instance, unique to that instance. But the class variable pi is shared among everybody in the class, right? So those are useful for basically being able to keep track of stuff or constants. Final, double pi. Final, can't change it. Double, that's what type it is. Pi, that's the variable name. So something we could do over here is private. Not everything is, by the way, not everything is a public variable. Or not every static variable is a public variable. Here's one that we could do. Num circles is equal to 0. Public static num circles is equal to int num circles. We initialize num circles to 0. And what we'll do is that every time we create a circles, we'll do num circles plus plus. And this will keep track of how many circles we've created. So now if we run into this, oh, by the way, this program is still running. So we'll stop it by hitting that button, right? Because it was debugging. And what had happened is that once we got here, it stopped before going into the for loop. So it's a very useful tool, and then you can move line by line and see what happens to your program. But let's go ahead and now print out circled. And we can write a getter for this, by the way. So we'll need to because it's private. Public int get public static int get num circles. So it's a getter for a static variable, right? You need it to be static because it's a static variable. Well, that's actually more suggestion, but now we can say, hey, after this is run, we've printed 1,000,000 circles. So static means that it belongs to the class. The final thing I would like to mention is the toString method. So so far when we've been printing stuff out, I've been writing a print method, but really what every variable has, and we'll discover why in the next module, module 4. Every variable has a bunch of built-in methods. Sorry, not every variable. Every single class has a couple of built-in methods. So, for instance, if I have a circle, so for instance, if I do circle C is equal to new circle 5, and I just simply say C dot, and a bunch of things come up. Equals hashcode toString. A bunch of these are basically stuff you get for free, but you can change if needed. So we're going to go ahead and do that now. I accidentally deleted that. Okay, so one of those is toString, public string toString, which Java looks for. And this is what defines the behavior of print of whenever we print out something. So, for instance, circle, I'm a circle. So let's see. So before, if we print out C, okay, should just comment this out. You get circle at memory location like we've been doing before. If, on the other hand, we comment this out and have ourselves a toString method and run it, we get I'm a circle, which is kind of useless, but it's different. Instead, what we could do is we could print out more useful information, like circle with, well, let's go ahead and ask this to generate a toString. Print out the radius. Return circle with radius equal to, yeah, sure, that works. Or we can just simply say circle with radius, and that works just fine. Circle with radius, public string toStrings, circle with radius plus radius. And now if we run it, create our 1,000,000 circles, and then we run this one that says circle with radius 5.0. And now if I go ahead and run this code actually over here, instead I decide to print out circles I, the ith circle. Rather than printing out a bunch of memory locations, I'm getting the radius of each of those.